Ji, am I audible?
Yes, sir.
Okay. In the last class, we have finished the entire syllabus. Now we will start revision. So in revision, I won't be taking any complete topic. What we will do, we will make a brain map of each chapter, and then we'll solve some good numericals over it. This is how we'll. So we'll first make mind map of first chapter, electric charge. The electric charge and field starts with the concept of electric charge. So the first thing is, what is charge? Charge is a property of matter. Then after charge, you should know the SI unit of charge or the charging methods of charging. We have three methods of charging. Does anyone remember what are the different methods of charging?
Conduction, induction, and friction.
So first one is friction. Then we have conduction. Then we have induction. So in friction, what we do, we rub two bodies and charge get transferred from one body to another. In conduction, charge conducts from one body to another, and in induction, charge is induced. Next, we have some properties of charges. Properties of charge. So we have three properties of charge, which is charging by the first property is additive nature of charge. Additive nature of charge.
Quantization of charge.
Second property is conservation of charge. Third property is quantization. So out of all these properties, this quantization, you can get questions from the quantization only. It's very rare that you get questions from any other topic. The majority of question that you get is from quantization of charge. So quantization is this: Q is equal to N. Where Q is charge over the body, N is number of electrons transferred, and E is charge of it. Although there are very, very rare chances that you get questions from this charge. The next topic is Coulomb's law. This topic is important from the point of view of numericals. So in Coulomb's law, we first have the concept that what is Coulomb's law? It's if you have two charges, Q1 and Q2. They are placed at a separation R. The force between the charges is K Q1 Q2 divided by R square. Where K is a constant, you can write the value of K is 1 over 4 pi epsilon naught. This is Q1 Q2 divided by R square. So this is the expression of force when charges. This epsilon naught is absolute permittivity of free space. You can use this expression only when your charges are in free space. But if you place your charges in medium, so this is in free space. When you place your charges in medium, the expression of force is 1 over 4 pi K epsilon naught. It's Q1, it's Q2 divided by R square. This is the expression of force, where this K is the dielectric constant. K is the dielectric constant of the medium. So if your charges are placed in free space, then we use this expression. But if your charges are placed in some medium, then we use this expression where K is the dielectric constant. These two expressions, this is in free space, this is in medium. This is valid for two charges only. If you have more than two charges, for n charges if you have, then we use superposition principle. Superposition principle. Superposition principle says if you have more than two charges, let's say you have a system having a charge Q naught, you have a charge Q1, you have a charge Q2, you have a charge Qn, and let's say all the charges are positive, then each charge will exert some force over Q naught. This is force on Q naught due to first charge. This is force on Q naught due to second charge. This is force on Q naught due to nth charge. And the net force is the vector sum of individual forces. Keep on adding. It's F01, F02, F0. So the net force on a body is algebraic vector sum of individual forces. This is superposition. So point of view of numerical, this is an important topic. You can get numericals from the superposition. After superposition principle, we have the concept of, no, like, let's first solve numericals up to superposition principle only. No need to take notes. You already have these things in your class notes. No need to take notes from me. I'm just reminding you the relations. If you have any doubt up to this section, I can discuss those doubts. Otherwise, we'll move on to numericals.
So we have to do the derivation. Like, is it important?
Derivation, the important derivation from Coulomb's law is Coulomb's law in vector form. That's it. It's Coulomb's law.
And the derivation of Coulomb law.
No, that's not a part of it. We don't derive, we just put F is proportional to Q1, Q2, and R square. That's it. Coulomb's law in vector form, this is the derivation that you should. Any other question, if anyone want ask, we can discuss. Otherwise, I'll move on to numericals. See, my motive is to solve numericals. Sakina Abbas, Sakina, Nazia. No. Okay. Remember, to solve numericals of Coulomb's law, you should know vectors. This is important. You cannot solve numericals of Coulomb's law if you don't know vectors. So vectors are important. So let's move on to this is the assignment. These assignments are already in your student account. So I'm taking important questions. Just solve those important questions because the last time you can't solve all of them. So this is one good question. You should solve this question. I will solve this question and you'll do this as an homework. You can note down the question number. You can note down the name of the assignment. You can get it from your mobile app or your web app. And then there is one more important question. That's enough. So let's solve this question. You have two identical charges, capital Q each, are kept at a distance r from each other. A third charge Q is placed on the line joining the above two charges. So let's first draw the diagram. This is question number 6. See, to solve numerical, the very first step is at least draw a rough sketch using the given data. So you have two charges, capital Q each. So one charge is Q, another charge is Q. They are placed at a separation r. Okay, this will be easier. Okay, let's solve question number 7. This is very easy. This will be your homework. I'm solving 7, not 6. So you have 2 point charges plus 4e and plus e are fixed a distance a apart. Where should a third point charge be placed on the line joining so that it may be in equilibrium? So you have a charge plus 4e. Then you have a charge plus e. Both the charges are at a separation a apart. This is the line joining the two charges. So you need to place a charge Q on the line joining the two charges. So let's say you place a charge Q here. From first charge, the separation is x. From the second charge, the separation is a minus x. So let's call this point as A, let's call this point as O, and this point is O. Let's say it's a positive charge. So question says this charge is an equilibrium. What does equilibrium means? Equilibrium means net force on the charge is 0. Now decide which charge, which charges will exert force on plus Q. So this plus 4E will exert a force on plus Q. 4E will repel this plus Q. The name of the force is force on charge at O due to charge at A. Similarly, this charge at B will repel this charge at O, and this will be the direction of force. The name of the force is force on charge at O due to charge. See, both the forces are in opposite direction, so they can cancel out each other. So for equilibrium of Q, the vector sum of both the forces should be 0. Now, but since both the forces are in opposite direction, when you add them up vectorically, they get subtracted algebraically. So you can write it as FOA minus FOB is equal to 0. Or you can say that FOA is equal to FO. Now just substitute the values. This is charge at O. This is charge at A. The separation between them is X. So the force is, it's 1 over 4 pi epsilon naught. It's small q. Then this force F4E divided by the separation between them, it's X square. Similarly, you need force over this charge Q due to this charge plus E. So the expression is again 1 over 4 pi epsilon naught. It's Q. It's due to E divided by whole square of E minus X. So this 1 over 4 pi epsilon naught, 1 over 4 pi epsilon naught gets cancelled out. This Q gets cancelled out. E will cancel out. So you have 4 by X square is 1 by A minus X whole square. When you take roots on both the sides, you get 2 by X is 1 by A minus X. Just cross multiply them. So you have 2A minus 2X is equal to X. So you have 2A is equal to 3X. So you have X is equal to 2A by 3. So for a charge Q to be in equilibrium, it should be placed at a distance X, which comes out to be 2A by 3 from the charge. This is question number 7. So do it.
Where the position of equilibrium will be center always.
No, it's not the center. See, this is 2A by 3. Center would be at A by 2. You are asking, why is it in between the two charges?
Yes, sir. Plus Q.
Because if you take plus Q here, see, then charge of A will repel this Q, and this plus E will also repel this Q. Both the forces are in same direction. So they don't get they will get added up. They won't cancel out each other. So
Okay.
do it. And don't copy this numerical. Read this question. Don't repeat, don't just copy the numerical. Just read this question and do it on your own. If you're stuck somewhere, just ask. This question will be your homework. Question number 8 will be your homework. We'll do one question from each type. I will do one question in class, and what would be your homework? And please don't copy this. If you copy this now, you won't be able to write this in your exam. No need to write the question, just write question number, assignment number, and then Yes, can I move on to the next question? Arpit,
Wait a second,
Ishma,
sir, I'm doing it.
Saifullah.
1 minute, sir.
If you have doubts, we can discuss. Naziha, Sakina, Ishma. Tell me if you have doubt in any step. Okay, Naziha, Sakina, and Sakina Bas. You haven't done first book with me. You want to do the complete book also? Or you just want discussion of numericals?
Numericals are fine, sir. If I'm finding difficulty in certain topics, I'll ask you.
Okay. And Sakina? Sakina Bas?
Yeah, it's numericals is fine.
Yes, sir, same.
Okay. And the
We
question
can
that I
leave the x in terms of a.
yes. And the questions that I'm leaving for homework are important. Go through them. If solution of any
Done.
question is not available in the assignment, then what you can do is copy that question, paste it on Google, and then you can find. Sorry. Sorry. So if the solution of any question is not available in the app, then you can just copy that question, Google it, and you will find solution everywhere. These are previous year's questions. The solutions are easily available. Okay, so that was one question. The next is so okay. After Coulomb's law, the next topic is electric field. So let's just recall all important relations of electric field. See, electric field is the space around a charge in which the electrical properties of a charge exist. So the general formula for the electric field is, if we talk about the general formula. For electric field, the general formula is this. Electric field is force experienced by test charge divided by the magnitude of test charge, provided limit Q tends to 0. It's F by K. Next, you can divide this. This is a general formula. This is valid for all types of configuration. Next, what we can do is we can derive relations from individual charges. Like we can have a relation for electric field of a point charge. So if you have a point charge and you want to calculate field at a separation R, at a separation R, the expression of field is its kq by r square, where k is 1 over 4 pi epsilon naught. It's kq by r square, where k is 1 over 4 pi epsilon. We can have electric field for a dipole also. So in dipole, further 2 points are important. One is axial line, another is equatorial line. On axial, the expression of field is it's k2p divided by r cube. On equatorial, the field is it's kp by r cube. So this is about electric field that one should know. Expression of point charge, dipole, and yes, superposition principle also. Means if you have a single charge, then you can easily calculate field using kq by r square. But if you have a number of charges, then for the net field, what you will do is you will add them up vectorically, E1, E2, En. Just add them up vectorically. That's the expression of it. Now let's see some numericals. These type of questions are important. This type of questions. Let's solve this question and This will be your homework. This is topic number 3, electric field. So you have two charges, 16 microcoulomb and minus 9 microcoulomb are placed 8 centimeter apart. Determine the position of the point at which the resultant field is 0. One more thing is important, that is the direction of field. So if you have a positive charge, then for the positive charge, direction of field is away from the charge. But if you have a negative charge, then direction of field is towards the charge. Now let's solve this numerical. So first, draw a rough sketch. See, the initial steps for solving a numerical are common throughout physics. Just draw a rough sketch. The separation is 8 centimeter. Note down the given data. R is 8 centimeter. You have to convert all in SI unit. Remember, class 12 syllabus is in SI unit. So you have to convert all terms in SI unit. Don't keep anything in CGS. Minus. Q1 is 16 microcoulomb, which is 16 into 10 raised to the power minus 6 coulomb. Then you have Q2, which is minus 9 microcoulomb, which is minus 9 into 10 raised to the power minus 6 coulomb. So you need to calculate the position of a point where net field is 0. So let's take this point. This is point. This is charge A and this is charge. So the point at which net field is 0, you have to decide that point could be anywhere. This could be here, or the point could be here, or the point could be here. To get the region in which region 1, region 2, or region 3, the region in which this point can exist, you have to decide the direction of it. See, at point P, the fields due to both the charges will cancel each other. Fields can only cancel if they're acting in opposite directions. So to decide the region, the first step will be decide the direction of field. If direction of fields are opposite, that means they will cancel out each other, otherwise they will get added up. So in region 1, this is positive charge. The direction of field is away from the charge. This is negative charge. Direction of field is towards the charge. See, both the fields are in opposite direction. They can cancel out each other. Means point P can lie in region 1. In region 2, if you take, this is positive charge. Field is away from the charge. See, this is negative charge. Field is towards the charge. They don't cancel out. They will get added up. So point P cannot be in this region. We check here. This is minus. The direction of field is towards the charge. This is positive. Direction of field is away from the charge. It can cancel out. So the point P can lie either in region 1 and then or in region 3. Then there is another trick. You have to decide out of region 1 and region 3 in which this point P should lie. So remember, the point at which field is 0 will lie near the smaller charge. We call this type of points at neutral point. If you check your notes, it's there. Neutral point lies near smaller charge. Point charge, smaller charge. So out of 16 microcoulomb and minus 9 microcoulomb, minus 9 microcoulomb is a smaller charge. So your neutral point will lie here. Let's call this separation as R. Let's call this separation as some R plus 8. Net field over this point is 0. Due to this charge at A, this is the direction of field. Due to this charge of B, this is the direction of field. So net field is 0. That means field due to charge at A plus field due to charge at B is equal to 0. Now, since both the fields are acting in opposite direction, they will get subtracted out. So EA minus EB will be equal to 0. Then you have EA, which is equal to E. EA means field due to this charge. So the charge is 16 microcoulomb and the separation is R plus 8. So this is KQ by R square. For a point charge, this is the expression of field, KQ by R square. So we'll put K as it is. Q is this. 16 microcoulomb, so it's K into 16 microcoulomb, 10 raised to the power minus 6, divided by square of separation, which is R plus 8. So this is R plus 8 square. When we calculate EB, see from B the separation is R, so it's K. Q is 9 microcoulomb. When we calculate magnitude, we don't substitute the sign of the charge. We will not put minus sign here. 9 into 10 raised power minus 6, and the separation here is R also. Now this K will cancel this K. This 10 raised power minus 6 will cancel this 10 raised power minus 6. You can take roots on both the sides. You will get 4 by R plus 8 is 3 by R. So when you cross multiply them, this is 4R is 3R plus 24. Okay, 3 into R and 3 into 8. So you have R equal to 24 centimeters. So the point at which the net field is 0 will lie in region 3 at a separation of 24 centimeters. There is one question, why I'm getting my answer in centimeter? Because I'm taking here this 8 in centimeters. I'm taking this length in centimeter. That's why I'm getting my answer in centimeters. If you multiply it by 10 raised power minus 2, then you will get your answer in meters. But here I'm taking this in centimeters. Note it down. If you have doubts, I can discuss. And I will appreciate if you can just pinpoint your issues. If you have issues in a particular step, you can pinpoint those steps. It will be very helpful for you.
So can you explain that how to determine the direction?
The direction of field is for a positive charge, it's always away from the charge. And for a negative charge, it's towards the charge. So if you look at here, this is a positive charge. So the direction of field is away from the charge. So you are going away. This is E. This is negative charge. You need direction of field over this point P. It's towards the charge. Towards. Right? After
Yes, so
and please don't copy the solution. These questions are from PYQ. Maybe you can get these questions this year also. Do it on your own. If you stuck somewhere, just ask. And I will give a similar numerical as a homework exercise. Try to learn how we solve numericals. If you solve 20, 25 numericals with me in classroom, you will be able to solve the others also. But if you copy those numericals, that won't help. Vishma, any issue?
No, sir.
No, pre-board is over.
No, sir.
Sefula, any issue in calculation?
No, sir.
What's the status of your pre-boards, Savala? Are they over or still?
Sir, they are going to start from this 29th of Jan.
And if you're solving from these assignments, don't do this level 2 and level 3. Just concentrate on level 1. That's enough for his basic exams. I believe you must have written up to it. Huh? So this question number 4 would be your homework. Just try this question, it's an important question. Now let's move on to the next topic. Usually you don't get numericals from electric dipole. But if you want to solve some numerical, then you should solve this one. Usually you get a theoretical question or derivations from the electric field of dipole on axial line and equatorial line. If you look at PYQ, maybe in 10 years you find one numerical on this electric and axial line. Otherwise, they always ask derivations or conceptual questions. After this, the next topic is electric field lines. Electric field lines. So in the first chapter, the first topic is charge. Then you have Coulomb's law with superposition principle and all. Then you have electric field, point charge, dipole, and superposition principle. Then you have electric field lines. See, electric field lines is an easy topic. I don't want to discuss it here. Just have to draw the field lines for various type of charge configuration. That's it. So if you go through the class notes, all systems for which we have drawn these electric field lines are more than enough for your coming exams. So usually you don't get tricky questions from electric field lines. So I will not be discussing this here, but after electric field lines, the next topic is force on charged particle. That's important. It's a very small topic, just two concepts, but you can get various numericals from it. Force on charged particle in electric. So if you have an electric field, and in this electric field E, if I place a charge Q, then what will happen? This electric field will exert some force over charge Q. This charge will experience a force QE. So if this charge is positive, it will experience a force in the direction of field. But if this charge is negative, it will experience the same force, but in a direction opposite to that of. So if you want to calculate just the magnitude of force, then this is QE. Plus and minus sign will decide the direction. So it's again, if you have an electric field and you place a charge in that electric field, then that charge will experience some force due to electric field. If that charge is positive, the force will be in the direction of field. If that charge is negative, then you will get force in a direction opposite to that. Now, on this concept, we have two types of questions. One is on one dimensional, another is on two dimensional. So this is a solid example of NCRT. This is on one dimensional question. This is solved. This is from the exercise. This is question on two dimension. These are the two type of questions that you can get from this topic. Topic small, just F is equal to QE. There is one more logic concept here. Okay, we'll discuss it later. So let's do one thing. Read this question. At least draw a rough sketch. We'll solve it together. I'm giving you 2 minutes. Just read the question. No need to write the question. Just write what are the given parameters. Draw a rough sketch. Try to identify the formula that you will be using here, and then we'll solve it together. So first step, draw a rough sketch. Second, draw the given parameters. Then decide which formula you will use here, and then we'll solve together. Okay, so let's solve it together. This question number 2 will solve. So in question number 2, he says that a electron falls through a distance of 1.5 centimeter in a uniform field of magnitude 2 into 10 raised power 4. So this is the diagram. Electric field is in upwards direction. Electron is a negatively charged particle. It will experience force in a direction opposite to that of field. That's why the direction of fold is downwards. So force is acting in a direction opposite to that of field. So electron is falling downwards. How will you calculate force? Using this relation, F is equal to Q. How much is Q? That's charge of electron, which is 1.6 into 10 raised power minus 90. Charge of electron is negative. I'm not using negative sign here because we are just calculating the magnitude. Then the electric field is 2 into 10 raised to the power of 4. This much of Newton is the force. The direction and for the time of fall in each case. So time of fall means you need time taken by the electron to travel from this plate to this plate. So from here to here, you need to calculate the time taken by the electron. So to calculate this time, what you can do is you have force. Using this force, you can calculate the acceleration, which is force by mass. So your acceleration will be this 1.6 into 10 raised to the power. Say this is minus 19 and 4, so it will be minus 15 into 2 divided by mass of electron, which is 9.1 into 10 raised to the power minus 31 kg. So it's meter per second square. This is acceleration. Now the distance between the two plates is 1.5 centimeter. This distance is 1.5 centimeter. So the distance that electrons will cover is 1.5 centimeter, which is 1.5 to 10 raised to the power minus 2. The equation is this: S is ut plus half at square. You can use this equation. Why we are using this equation? It's because acceleration is constant. Acceleration is not variable, it's a constant acceleration. So what you can do, just substitute the values here. So your S is 1.5 into 10 raised power minus 2. It starts from rest. So you can say that initial velocity will be 0. So u will be 0 plus half. Acceleration is this 1.6 into 10 raised to the power minus 15 into 2 by 9.1 into 10 raised to the power minus 31 into t square. That's it. Now you can get the value of t. You can easily calculate t, the time taken. Similarly, if you want to repeat this question for proton, see the direction of field is reversed because proton is a positively charged particle. It will go downwards only if field is acting in downwards direction. So instead of mass of electron, you will get mass of proton. Is it clear? Noha, Mehraj, Vishma,
Yes, yes.
Alia? Okay, just note it down. Do it on your own. We'll do question number 3 now. This is based on two-dimensional motion. The first one is on one-dimensional motion. When you revise any chapter, go through the numericals first. Huh? The major part of your paper will be numericals and conceptual question, not the derivations or theory part. So give maximum stress on numericals, not on theory. And please don't repeat don't copy the calculations. Do it on your own. Done? Okay, so
No,
let's
yes,
move.
sir.
Take your time, but don't copy these calculations. See, the toughest numerical that you can get in your paper are usually from electrostatics or from current electricity. I will try to cover all those questions. Also, just check the list of derivations. I have shared the list of derivation in the group. So when you prepare any topic, just check that list that you know all those derivations or not. I'm trying to share the list of important numericals also.
So what's the weightage of this chapter in the exam?
The weightage of chapter 1 and 2 combined is 8 marks. So it's usually 50-50. The maximum weightage from chapter number 1 goes to that Gauss law and flux. So, Saifullah, question number 3.
Yes, sir. You can.
Sorry. So, again, read this question. This is the rough sketch. And I'm just changing the question. Don't calculate the angle of deviation. Find the deviation of path, means you have to calculate this by. Just note down the question. No, sorry, don't need to note down the question. Just read the question, note down the given quantities, draw a rough sketch, and write the equations which you will need to solve this question, and then we'll start. First step, rough sketch. Second, note down the given quantities. Then try to decide what you have to calculate. Then the equation that we'll be using here. Okay. So let's solve this question. You're supposed to calculate this y. So see, this is an electron. You projected this electron along x-axis. The electric field is in the downwards direction. This electron will experience a force. This will experience a force in the upwards direction. So the force that this electron will experience will be is equal to E. Now, the force will act in the upwards direction, means along y-axis. And initial velocity of electron is along x-axis. The force is acting along y-axis. So simultaneously, the electron will have motion along x-axis due to its velocity. And due to the force, its motion is along y-axis. It will have motion along x-axis as well as y-axis. That means its path will be two-dimensional. So instead of going downwards or to the x-axis, it will go in this way. And when it move out of the field, this electron have deviated from its original path. The original path was this along x-axis. When it goes out of the field, it's here. So there is this y deflection that you are supposed to calculate. So to calculate this y deflection, what we can do is we will first calculate the force. Or this is clear from the figure that motion is two-dimensional. So first we will try to solve it along x-axis. So along x-axis, what is the force on electron? There is no force because force is applied by electric field. Electric field is acting along y-axis. There is nothing along x-axis. So there is no force along x-axis. No force along x-axis, that means acceleration along x-axis is zero. What is initial velocity along x-axis? This is the velocity with which you just project this electron, v0. So initial velocity along x-axis is v0. The displacement that this electron will cover along x-axis is L. So you can say that Sx is L. You're supposed to calculate time. Means the time taken by electron to move from here to here. So when electron moves from here, means from the starting of the plate to the end of the plate, along x-axis, it covers a distance L. So this Sx is equal to, we're supposed to calculate the time. To calculate this time, we use this equation, S is ut plus half at square. This is along x-axis, this is along x-axis, this is along x-axis. So ux is 0, can just, not ux is 0, ax is 0. So Sx is L, ux is v0, time is c. So the time taken by the electron to cover the length of the plate is L by v. In the next steps, you are supposed to calculate this y. So to calculate this y, what you can do is use the equation for y-axis. Now, force along y-axis is not zero because there is electric field along y-axis. So due to electric field, this particle will experience some force, which is E. So along y-axis, it will experience some force, which is E. This will have some acceleration along y-axis, which is force divided by mass, which is E divided by the mass. Then we have initial velocity along y-axis. So the initial velocity along y-axis is 0 because you projected this particle along x-axis. There's nothing along y-axis. So initial velocity is 0. The displacement along y-axis you're supposed to calculate. The time is same, like along x-axis and y-axis will take same time. Particle is ultimately start from here and reaching here. So the time will remain same whether you consider this motion from x-axis or from y-axis, the time is same. So here time is L by v0. So you can write y is uyt plus half ayt square. So you're supposed to calculate y, uy is 0, half ay is this thing e by m by time, which is L square by v0 square. So this is the y deflection of the charge particle. Do it on your own. This is question from NCERT, so you can get this question in exams also. Tell me if you have doubts. This is a very important question. This is in CRT, and this question was in previous years board questions also. Yes, written. Noah, any issue in this calculation?
No, sir. Yes, written. Can I scroll it now? Saifullah, Hishma, Arpit.
Yes.
Sure. Okay, after this, the next is don't just dipole. Next is electric dipole in uniform electric field. So if you have a uniform field, and in this uniform field, if you place a dipole, this angle is theta. So what will happen with the dipole is this dipole will experience a torque, and that torque is P cross E. Or this dipole experience a torque which you can write as PE sine theta. Due to this torque, this dipole will rotate and will try to align in the direction of it. Then there are three special cases. One is if theta is 0 degree. That means if dipole moment and electric field are in same direction, this is electric field. And this is dipole. If they are acting in same direction, theta is 0. Then if you calculate torque, then torque will be P sine 0. torque will be 0. This is known as the case of the stable equilibrium. Another case could be if your theta is 180. If your theta is 180, that means that electric field and dipole moment are in opposite direction. Your torque will be 0 again. Third case is if your theta is 90 degree. If your theta is 90 degree, that means this is electric field, this is dipole moment, they are at 90 degree. So your torque will be PE sine 90, which is 1. So body will experience a maximum torque, which is just. So this is the theory. If you place a dipole in uniform electric field, experience a torque, which is P sine theta. Then there are three cases. If theta is 0, that means torque will be 0, stable equilibrium. Theta is 180, unstable equilibrium. Theta is 90, it will be perpendicular, the torque will be maximum. Yes, let's see the first question. In a non-uniform electric field, if field is non-uniform, here if we calculate net force, then net force will comes out to be 0. This is when your field is uniform. But if your field is non-uniform, then it will experience a torque and a force. If you place a dipole in non-uniform field, experience a torque. This torque it will experience, along with the torque, will experience some force also. So this question is very important. This is from the PYQ of CBSE. Again, just read this question. Draw a rough sketch. Write down the given terms and try to write down the formula or the concept that we'll be using. Okay, let's solve this question. So in this question, instead of one dipole, you have two small dipoles of electric dipole AB and CD. Each of dipole moment P are kept at an angle of 120. So see, this is one dipole. The dipole moment is minus Q2 plus Q. This is P. And then you have another minus Q2 plus Q. This is P. The angle between both the dipoles is 120 degrees. So first calculate the net dipole moment. For this, you can complete the parallelogram. So when you complete the parallelogram, see, this is one dipole P. This is second dipole P. And they are acting at some angle of 120. So you first have to calculate the resultant. Or let's call this as P1. Let's call this as P2. Both have same magnitudes, but their directions are different. So let's add them up vectorically. So to add them up vectorically, you need this parallelogram law. So this is vector P1 plus vector. So P will be its root over P1 square plus P2 square plus 2P1 P2 cos 120. So how much is cos 120? That's minus half. This is P result. This is P result. P1 and P2 both are equal to P. So you can substitute P square plus P square plus 2P square. Cos 120 is minus half. So the resultant comes out to be, see, p square plus p square minus p square. So it's p square only. It's p. The resultant is. Next, what you need torque. Huh? What will the magnitude direction of torque acting on it? You need torque. So what is torque? P cross E. Torque will be P cross E. In this case, it will be P resultant cross E, or you can solve it in this way. P resultant E sine theta. So how much is P resultant? This is P, electric field is E. You need this angle theta. So see, if you are adding two vectors, then the result, and if both the vectors have equal magnitudes, the resultant will bisect the angle between. Means this whole angle will be 60 degree. This will be 60 degree. This is the direction of field. If that angle is 60 and the hole is 90, then this will be 30 degree. So the expression of torque is PE sine 30. Sine 30 is half. So your torque is PE divided by 2. It's a very important question. Do it.
So
Tell me if,
can you say how did you get angle as 30 degrees?
yes. See, both the dipoles, one is in this direction, huh? Another is in this direction. Angle between them is 120 degrees. So if both the vectors are of equal magnitude, then the resultant will bisect the angle between them. So this resultant P will bisect the angle. So this angle will be 60 degree and this angle will be 60 degree. You got this?
Yes, sir.
Now, this hole is 90 degree, right? This is x-axis and y-axis. This hole is yours 90 degree. This hole is 90. So this is 60, then the remaining is 30. Okay.
Okay, sir.
It would be better like if you first revise the chapter before this class and then you first discuss all doubts that you came across while revising, and then we can continue with the numerics. That would be a better approach. First, revise the entire chapter. Like in the next class, I will try to cover Gauss law and potential energy. So till next class, try to revise all those topics. So in the first 20 minutes of the class, we'll discuss if you have any individual doubts, and then we'll solve the queries. Haji, written?
1 minute. Yes, sir, done.
Okay. So today I'm left here only. In the next class, the target is Gauss law. potential and this potential energy for Wednesday. Try to cover these topics and solve these assignments, at least level 1. Level 1 you can solve. The questions in level 1 are either from NCERT or they're from previous years of board exams.